Hello everyone. Today we are going to look at different enabling technologies for IoT. So the enabling technologies are wireless sensor networks, cloud computing, big data analytics, communication protocols, and embedded systems. So let us look at each one of these things in detail. So first one is wireless sensor networks. So as the name implies, it is a collection of sensors which are communicating through wireless communication channel. Okay, so it's basically a collection of sensors communicating in a wireless mode. So typically you will have a collection of sensors which will be sending the data to sync node, or you can say gateway, and this sync node or gateway is responsible for sending the data to internet, where you can perform analytics on the data, and the extracted information will be used by different users through mobile applications or web applications. So let's look at some points regarding wireless sensor networks. So it contains different devices which will have embedded sensors that are used to monitor the environmental or physical conditions, like sensing the light or monitoring the temperature, humidity, etc. And wireless sensor network contains a number of nodes. These nodes can be either end nodes or routers or coordinators. Okay, a network coordinator. So if you take a wireless sensor network, you can find one or more coordinators, routers, or end nodes, which will contain sensors. So these end nodes can also act as routers. So, and what is the task of a coordinator is it collects data from all the nodes and sends that data to internet. And where these wireless sensor networks can be used is mm, weather monitoring systems, indoor air quality monitoring systems, soil moisture monitoring systems, surveillance systems, smart grids, structural health monitoring systems. Not only these things, these are only some of the examples. So these things can be, wireless sensor networks can be used in many of the IoT applications. Okay, so whatever IoT application you can take, in that you can use wireless sensor networks. And next one is cloud computing. So what is cloud computing means? It is a computing model which abstracts the resources that are delivered over internet, and those resources can be compute, that is CPUs, networking, or storage. And the famous thing about cloud computing is we can use the resources based on utility model, that is pay as you go, or you can say pay per use. Okay, so before going into further details, let's look at what is this cloud in cloud computing. So the thing you are seeing in the picture is a data center, one of the data centers that are there across the world. There are hundreds of data centers across the world. Some of them are maintained by Amazon, some of them are maintained by Google, some data centers are maintained by Microsoft, some data centers are maintained by IBM, and so on. Okay, so you can see these are very large in size. So this is a single data warehouse, and you can see on the road there are cars. Now you can compare the difference in size between them. So inside these data centers, you will find something called racks. So the installed structure is a rack, and inside these racks, you will find CPUs. Okay, so each one of these things is a separate system. Okay, like a PC or laptop or whatever you consider, each one of these things is a separate system with its own CPU, own storage, own RAM, etc. So like this, there will be hundreds of servers, I mean racks, inside the data center, and there will be thousands of systems inside these racks. Now, until now, what is this? We are seeing here, this is hardware, right? And to maintain this hardware, we need software like virtualization applications, operating systems, utility applications, or whatever you consider. We need software to manage the hardware. Now, the combination of hardware and software is called cloud. Okay, so the combination of the hardware and the software used to manage that hardware inside a data center is called cloud. And cloud computing is providing these resources on a utility based model. Okay, now let's see the characteristics of cloud computing. So first one is on demand. So all the resources, compute, networking and storage, all these things are available based on demand. If the number of if the traffic increases, the resources should also increase. If the traffic decreases, the resources will automatically scale down. Okay, that is decrease. Next characteristic is autonomic, means this scaling up and scaling down of resources based on demand is done automatically. No need to go and see manage the resources. Okay, it is automatic. And next property is scalable, also called elasticity. So as I already said, the resources will scale up and scale down, that too automatically. So this property is called elasticity. And the main thing about cloud computing is pay per use. The utility model I am talking about is this one, pay per use. So it is as an example, you can consider this. Using 100 systems for 1 hour is equivalent to using one system for 100 hours in cloud computing. That is because of this pay per use. And last characteristic is ubiquitous. So all these resources in the cloud, if you have the subscription, they can be accessed from anywhere across the globe as long as you have internet. So that is the meaning of this ubiquitous characteristic. All the resources are available 24/7 across the globe. The only thing you need to have is internet. Next, cloud service models. So as I told you, cloud provides different resources like CPUs, that is compute, networking and storage. So in what way they are provided, or in which way we can subscribe to those resources. So there are generally three service models: SaaS, PaaS and IaaS. So first let's see IaaS. It is called infrastructure as a service. Okay, so here this is generally hardware. Okay, so what the cloud providers will do is they will have data centers. On top of data centers, they will install virtualization software, and then they will provide those virtualized resources to clients. So if someone is purchasing IaaS service, means they are purchasing either servers or storage or network or security or any other service. Okay, so if I purchase a server, uh, I can install whatever operating system I want. I can install whatever applications I want on the server. Okay. It is client's wish. What the client wants to do with the server or storage or whatever. And next one is PaaS, platform as a service. So PaaS provides runtime environments. This is typically used by developers. Okay. So what the cloud providers will do is, after virtualization, they will install the operating system and they will install whatever programming environment that is needed. For example, they will install Python runtime or Java runtime or any other language runtime and provide that as a platform. Okay. So as a Java developer, I will purchase PaaS service which provides Java runtime for me. Once I purchase the Java runtime service, I can develop applications, my own applications using Java. So that is the use of PaaS. And last one and very popular one is software as a service. We are daily using this thing. Maybe you don't know about this. If you take Gmail, it's a software as a service. If you take Google Drive, it is software as a service. If you take Dropbox, it is software as a service. If you take Netflix, it is software as a service. Many of the applications are running as software as a service on the cloud. So users who use them, they can interact with the application. Other than that, they can't do anything. Okay, so they have control only on the service. Other than that, they can't manage any other parameters. Like you can't say I want to use Intel CPU. It is not possible in SaaS. Okay, right. And next one is cloud deployment models. So based on how cloud is created, we have different deployment models. So first one is public cloud. So if you are using Gmail, you are using a public cloud. Similarly, if you are using Netflix, you are using a public cloud. Okay. Mm. So different features of public cloud is elasticity, that is the resources scale up and scale down based on the demand, and you are charged based on how long you are using the resources, and it provides expertise, that is for example, if you are using Google public cloud, there is no need for you to worry about updates and all these things for the software. Google will automatically update and patch all the systems. Okay, right. And next one is private cloud. That means if you are purchasing private cloud, you are using that is the cloud provider, either Google or Amazon. They will reserve the resources only for your organization. Okay, they will not share those resources with other people or other organizations. It's private cloud, it is your own. So as you are the owner, you have the total control over the private cloud, and you can follow all the regulations, and it offers flexibility. And that is, you can install whatever you want and you can implement security controls and all these things. So it provides total flexibility. And next one is community cloud. So this is, let's say one data center is used by two or three organizations like HP, IBM, and Microsoft. Okay, so the resources in the entire data center are shared by three organizations that for common goal, whatever they want. So that is called community cloud. And last one is hybrid cloud. So combination of any of these things is a hybrid cloud. So typically nowadays organizations are using hybrid cloud, where they will use the private cloud as well as public cloud. So they will store all the sensitive information like mm, maybe stock information, sales related data, employee related data on the private cloud, and on the public cloud they will store non-secure data. Okay, that means even the data is exposed to the public, there is no harm. Okay, and next we are moving on to the another enabling technology, big data analytics. So let's talk about big data. So it is a collection of data from various sources, and it is often characterized by three V's initially. One is the volume of the data, variety of the data, and velocity of the data. So initially when big data was popular, there were only three V's: volume, variety, and velocity. Later, three more V's were introduced: veracity, value, and variability. Okay. So volume means huge amount of data is being generated on the internet nowadays. Variety means different types of data: structured, semi-structured, and unstructured data. And all this data is produced within seconds or milliseconds, so the velocity is very high. And veracity means the degree up to which the data is trusted. So even though you have large amounts of data which is not useful, then it doesn't help my organization, okay, to get profit. And value of the data that is collected, just like I said, if the data doesn't contribute to gain profits, it is useless even if you have so much data with you. Variability, so the ways in which the big data can be used and formatted. So this is related to representation of the data. Okay, so these are the six V's. And next, so we are looking at the steps in data analytics framework. So first one is collection of data. So whatever sources we have, we collect the data in different formats. And then next step is cleaning the data. So if there are any missing values, you can fill them. If there are any erroneous values, you can remove them. You can label the data, you can structure the data, and you can add context to the data. And next step is integration with existing data sets. Okay, you combine the new data with existing data. And then next step is analysis. Once you have the data, you perform analytics, either descriptive analytics or predictive analytics or descriptive analytics, where you apply different concepts from different domains. And then next step is visualization. Okay, so you represent the information after the analytics as diagrams, graphs, that is the visualization. And finally, based on the graphs and all these things, you produce alerts, either push notifications, email notifications, or generating figures in the dashboard and all these things. So this is the data analytics framework, and you can see examples for this framework. So first step is collection, and next you have cleaning and integration, and next you perform analytics, and finally you represent the findings and generate alerts. Okay, right. And next enabling technology is the communication protocols. Like I already said, communication is very important in IoT. They are the backbone for IoT systems. So without communication, devices will not be able to send data or receive data. So that is why communication is very important. And protocols play a significant role in communication. So what is the use of protocols? They provide the syntax, that is the format, data encoding, and addressing schemes for devices. And they also include flow control, error control, and other functionality. And last enabling technology is embedded systems. Mainly you find these embedded systems in the device layer. Okay, right. And embedded system is a combination of hardware and software which is used for a specific task. So examples: digital watch, digital washing machine, digital refrigerator, digital AC, anything you take digital, that is a embedded system. Computer is a more generalized system. So you can do a lot of things with a computer. It's not a specific thing. It's a generalized system. Okay, right. And any embedded system will contain some key components like microcontroller, microprocessor, memory, networking units, input, output, and storage. And these things run special kind of operating systems called real-time operating systems, RTOS. So that's it about the enabling technologies for IoT. So we have wireless sensor networks, cloud computing, big data analytics, communication protocols, and embedded systems. Thank you.